Good afternoon, Year 6. I'm here to help you a little bit with your work today. We're starting off with looking at working out the total of the interior angles of different polygons. So here's the pentagon that they started us with. You can see here that, like in the example they've given you, I've split it into 3 triangles. If we go on the premise, on the fact that every triangle has an internal total number of angles, of interior angles, of 180 degrees. Remember, a straight line is also 180 degrees. We know that a right angle is 90 degrees. So the number fact is that the total interior angles of a triangle is 180 degrees. So looking at this polygon here, this pentagon, I've split it into 3 triangles. So to work out the total interior angles, I multiply the interior angles of a triangle by 3, and that will give me the total interior angles of a pentagon. So if we did 180 multiplied by 3, the total internal angles of a pentagon would be 540 degrees. So then thinking about the next bit, so the next question, it's got a 1, 2, 3, 4, 5, a 6-sided shape, which we do know is, that's right, a hexagon. So we know we've got 6 sides, so I'm going to pop that there. So how many triangles can we do? So I'm going to join up, so that's a 3-side, that's 1 triangle. There's another one here, 2 triangles. Another one here, that's 3 triangles, and then I can see that I've got a 4th triangle in the middle. So there are 6 sides, there are 4 triangles. Now I know that there are 4 triangles, so the number of triangles that I've got, which is 4, and I've got to multiply that by 180 so that I know then what the total of the interior angles is. And I'm not going to tell you that because you can work that out yourself. Likewise with the next shape, so for question C, I will be doing the same. I'll be working out the number of triangles. Obviously I'll be using a ruler in my jottings. This one's a bit more complicated, isn't it? Because I've got a quadrilateral in the middle there. So I'm going to need to turn that into 2 different triangles so that I can see 1, 2, 3, 4, 5. 5 triangles. How many sided shape? 1, 2, 3, 4, 5, 6, 7-sided shape. So 7 sides, and I've got 5 triangles, and I can see how to work that out. I would multiply the number of triangles by 180 because that is the total interior angles of a triangle, and that would give me the total interior angles of this heptagon, this 7-sided shape, a heptagon. Okay, so moving on to question 2 then, it's really important that before we do that, we think about this question here. What do you notice about the number of sides compared to the number of triangles? So what is the pattern here? Well, if we have a little look at this, a 5-sided shape has 3 triangles. A 6-sided shape has 4 triangles. And a 7-sided shape has 5 triangles. So you might have worked out then, here we go, that the number, that you can look at the number of sides, you can take 2 away from the number of sides to work out the number of triangles, or you can add 2 to the number of triangles to work out the number of sides. So just bear that in mind, however you want to remember it. You can write it algebraically if you wish, and I can email you individually about that. I can put it on Google Chrome if you request it. So that's quite an important rule to complete table 2. So you can see here that if you've got a number of sides, we know that a pentagon, we know how many sides that has, and if we take away 2 from the number of sides that a pentagon has, it will give us the number of triangles needed. We can multiply the number of triangles by 180 to work out the sum of the interior angles. Like here, the quadrilateral, it's got 4 sides, take away 2 is the number of triangles, multiply 180, the interior angles of a triangle, by 2 to give us 360, which we also know is the sum of the interior angles of a circle and of a square and a rectangle. So you can work through, you'll need to go backwards in this one here. We know the number of sides, take away 2 is the number of triangles. The number of triangles add 2 is the number of sides. And this one, you'll have to work out, you'll have to divide this one by a particular number to work out the number of triangles, the number of sides and what the shape is. But I think you should know your place value well enough to be able to do that. So the next challenge is this one here, number 3. So it's an 8-sided shape. I've copied it out on my paper here. 1, 2, 3, 4, 5, 6, 7, 8. So we know it's an octagon. Octagon. So it's an 8-sided shape. Now what the person on here, Danny, has done is they've divided it into 10 triangles, and they're all lovely triangles. But I just want you to think if it's necessary to use that many triangles in our polygon. It doesn't really fit in with our rule of the number of sides, take away 2 is the number of triangles. So just have a think about whether or not she's done this right. And this is where it starts to get even more exciting here. So for question number 4, we've got Rosie, Amir and Eva. So Rosie says she split her polygon into 4 triangles. Okay, so what polygon has she drawn? Well, if she split it into 4 triangles, let's go back to our rule. We know that the number of triangles plus 2 is the number of sides. So if she's done 4 triangles, we just add 2 to that and it gives us 6 sides. And we know that a 6-sided shape is indeed a hexagon. And you just need to work on that basis with Amir's. So you need to think about the interior angles. What would you divide that by to work out how many triangles were in there, to work out how many sides there were? Likewise, for